Hey guys, my name is Irving, and I wanted to apologize that Amir and myself are not going to be here today. We instead made a recording of what we're going to say to go along with the slides. That way you guys know what is going on with our project. Now, I want to start off by saying that our project is the Healthy Heart. Now, I remember everybody that day was kind of frantic of choosing a project that we had to do for the Internet of Things project. I can recall that day, and most of us were feeling a little frantic about what kind of project we were going to do. We, as a group, decided that we were going to do something with the human body. Transmit our data over the Internet and make ourselves better, and we thought, how can we make ourselves better? What kind of data can we get from our body? And we thought that our heart rate is something that we want to monitor and process. And we could do that through the Healthy Heart and the programming that we're going to do to go along with it. So what we're going to be doing today is a little introduction of what Healthy Heart is, the list of materials that we use in the project, and a simple explanation for what they do and what they are. The schematic layout of what it is, and also the application, essentially what it does. Do you care about your body? If so, Healthy Heart is a way to help you maintain a healthy lifestyle. Be rest assured that this is no placebo. It will monitor your heart rate and process that data across the Internet into our program. Here is a list of materials that we use for the Healthy Heart. One of them was the Arduino Pro Mini. We'll explain why we use the mini version. We also use the pulse sensor, which is the actual main component that we use in our circuit to read the data from our bodies. We also use a gyroscope and an accelerometer in order to detect motion. We use an RF link transmitter, so that way we can transmit the data from the actual Healthy Heart circuit back to the Internet. And we used two 3.7 volt lithium ion batteries. That way it can actually power the circuit itself. And I'll pass it off to Josh so he can tell you more about the components and what they are and essentially what they do and why we picked them. Thank you.
The microcontroller we chose to use was the Arduino Pro Mini. We chose a specific one mainly because of its small size and its ability to process data. Comparing this to the Arduino Uno, the Mini is about 1/6 of the size and weighs less than 2 grams. It packs almost as much power as the Uno does. The Mini operates at 3.3 volts, while the Uno at 5 volts. At first glance, you can see that the Pro Mini only has pins on 3 of the 4 sides, and the pins on the short side are the programming headers, while the other 2 sides are a variety of power and general purpose input-output pins. The Pro Mini has 14 visual input or output pins and 6 analog inputs, and it also comes with its own built-in power and status LED. The common way the Pro Mini is powered is through a USB that is connected through the 6-pin programming header, or through a 3.3 volt supply through the VCC pin. Also, a common feature is whenever the Arduino is connected to a computer, it resets each time the connection is made from the software via USB.